Hello science fans and welcome to SHE-ensya. Our topic for today, your results, discussion, and conclusion. From our last discussion on research writing, we focused on chapters that can be found in your proposal. And this includes your review of related literature, your introduction, and your methodology. Now let's assume that it's a couple of months or maybe a couple of years later, and you're now ready to write your complete scientific paper. After a few tweaks on the chapters that were in your proposal, you're now ready to talk about your results. So let's see what you're supposed to do. When writing the results and/or discussion, one of the first decisions that you have to make is whether to write it together or separately. The quickest answer to that, of course, is dependent on the regulations of your university or the journal that you're submitting your paper to. Separate results and discussions can allow you to focus first on what your results actually show without worrying about the implications. It can allow you to talk about the trends present in your data without having to explain the reason for the trend. On the other hand, if your discussion does not reiterate the results because you want to avoid redundancy, readers may have to go back to your results frequently to understand the flow of your discussion, and this can be very distracting. On the other hand, if you write your results and discussion together, it allows you to dive into the implications of a specific result before moving on to the next. You are allowed to paint a cohesive picture of the meaning of your results before you talk about other facets or aspects of your research. However, if not done properly, your discussion can end up being truncated because some individuals interpret their description of the results as discussion already. So you have to be conscious of the difference between the contents of the results and the contents of the discussion. So let's talk about what your results chapter should contain. It should have your key experimental results. And this does not mean your raw data. You have to sift through all the results that you were able to get and figure out which portions are relevant to the objectives that you set out to do. Another important portion would be the statistical analysis that you were able to do because these imply whether or not the results of your study are significant. Shown in the slide are examples of datasets that I presented in my own study about the species identification of juvenile mangrove crabs. As you can see, instead of talking about which individuals out of the 1,100 plus crablets that we were able to process were identified as a particular species, we decided to present it as a percentage instead. Also, instead of showcasing all the pictures of the frontal lobe spines, I highlighted portions that show aberrations that were present in incorrectly identified samples. So these are key experimental results that are truthful to the trends that I was able to see in the bulk of my data. So as I mentioned earlier, you should not put your raw data in the results chapter of your paper. To know which results to put in your results chapter, you have to go back to your research questions and objectives. But please take note, it is not whether your data supports your hypothesis or not. It's about relevance. Now, you also need to consider how best to present your results. Should you put it as a table, as a figure, as graphs, or as text? Try to use a variety of different methods of presentation and consider your reader. 20 pages of dense tables are hard to understand, but so are 5 pages of graphs. But a single table and a well-chosen graph that illustrates your overall findings will make things much clearer. When you finally move on to your discussion, it should contain the following points: comparison with prior studies, causal arguments and speculations, and implications and possibilities of future work. So when you compare your data to previous work, and here we reiterate the importance of a solid review of related literature, This is the part where you emphasize your contribution to the status quo of knowledge. For example, the picture in the background shows you an agarose gel electrophoresis pattern of digested DNA fragments. These DNA fragments contain unique sequences that can tell us the species of mangrove crab that I used. Unique patterns will tell us what species it is. And as you can see, the data that I had was consistent with prior publications from Japan and Southeast Asia, which shows that for this method of species identification, we find a certain sense of consistency. Your discussion becomes challenging when all of a sudden your data deflects from accepted knowledge. At this point, you would have to delve into causal arguments and speculations behind the reasons of your data. I encountered such issues in my own study when I found at least 27 crablets that created different patterns once I digested the same DNA fragment. We couldn't figure out the reason as to why this is, but we were pretty confident that they were not because of carelessness or issues in the lab, because the data was repeated for more than 3 times per sample and the results were consistent. Here, we talked about the possible reasons for issues in the differences in the DNA sequence of these aberrant crabs, which includes mutation, DNA duplication, and even multiple paternity. Do not end with your discussion by just talking about your results. A good transition from your discussion to conclusion is by highlighting the future directions and the new hypotheses that your study has generated. Please be reminded that science is not about making dead ends. It is instead a way for us to map the knowledge available in the natural world, and new studies should tell us where to go next. In the photos I show you, we see here aberrations in the morphology of crabs that we were able to notice. And it would be an interesting direction for us to go to is to figure out why these aberrations exist. It's a happy day when you finally get to write your conclusion. After all, it is the last chapter that highlights the amazing contribution of your research into the scientific world. So what are the key aspects of a conclusion chapter? It's basically a 5-point strategy that begins with your research topic, followed by a reiteration of your hypothesis. Please take note that here we're talking about your experimental hypothesis and not the statistical hypothesis. If you do not know the difference between the two, I highly suggest that you visit my video on the introduction or the scientific method. You then move on to the summary of results and their implications, the impact and significance of your study, and once more on the future of your research. In the conclusion, redundancy is not just accepted, but it is needed. You have to highlight the most important parts of your research so that your reader is refreshed and retains it in their mind. So, if I may conclude our research on species identification in juvenile mangrove crabs, let me walk you through the important parts. First off, the research topic is that this study sought to check if consistent morphological markers could be found in Scylla juvenalis. Our hypothesis is that considering distinct genetic differences within the genus and existing morphological markers in adults, we can expect to find counterparts in juvenile stages with the same biological structure as adults. So this would refer to juvenile stages that already have a dorsal carapace as well as existing walking and swimming legs. So to summarize the results and highlight its implication, we state that the use of image analysis of the dorsal carapace revealed that the frontal lobe spine shape has features that can differentiate juveniles to species groups. And this separation to species was confirmed through genetic barcoding. For the impact and significance of the study, please try to avoid claiming world peace or something way beyond the scope of your study. In our case, we believe that our results are useful for fishermen so that they can verify if traded juveniles are of the species they prefer. This is particularly useful because out of the 3 species of mangrove crabs present in the Philippines, only one species, Sila serrata, is capable of faster growth and larger sizes upon maturity. And finally, for the future of our research, we can also use this to talk about the limitations of the study that we did. Because we are fully aware that for our results to be useful, we need to create a method to automate the identification because fishermen would be dealing with thousands of crablets at a single harvest so that they can actually use it on the field. So here we admit that there is a long way to go for our findings to become relevant. But it also helps us determine future directions that we should invest in and also find the needed expertise to include in our team so that we can proceed towards this future. So that concludes our short discussion on results, discussion, and conclusion. And it also caps off our research writing lecture series. I hope that these lecture series have been useful for you. And if you want to see more science goodness from our channel, please like this video and please subscribe to SHE-ensya. If you have any comments, questions, or suggestions, please don't hesitate to let me, your resident Filipina scientist, know in the comments section below. Again, thank you very much for watching and see you around!